Hello, everyone, and welcome to today's To and Through Research Spotlight. I'm Thomas Massion. I'm a research analyst with the To and Through project. And yeah, just a few words before we begin. For some context, the To and Through project hosts these spotlight sessions to bring forward some really great practice, data, and research efforts happening in Chicago and around the country. And here at the To and Through project, we aim to significantly increase high school and post-secondary completion for under-resourced students of colors in Chicago and around the country by providing education stakeholders with research-based data on students' educational experiences and facilitating dialogue on its implications for adult practice. And so that is what we'll be doing today. And just to give you a brief rundown of today's agenda. So Dr. Irizarry, our speaker, will be presenting for about half an hour. And following that, we'll have a Q&A with the audience, you all, for about 20 minutes. And to submit your questions, please use the Q&A button at the bottom of your screens. And now to introduce our speaker for today, who I'm really excited to share with you all. Our speaker is Dr. Yasmiyn Irizarry. Dr. Irizarry is an assistant professor of African and African diaspora studies and faculty research, and she is a faculty research associate in the Population Research Center at the University of Texas at Austin. Dr. Irizarry is a quantitative sociologist by training with expertise in race and racism, intersectionality, and critical quantitative methods. Her research focuses on inequality in K through 16 schooling contexts, with particular emphasis on STEM, racial identity, description, and measurement, and as well as social attitudes, prejudice, and discrimination. Dr. Irizarry's current work examines the linkages between community, district, and school level factors and the prevalence of a racialized tracking in mathematics in U.S. public high schools, and the effects of racially tracked environments on STEM learning and persistence at the intersections of race and gender. All right, now I will hand it off to Dr. Irizarry.
Thank you so much, Marcin. Thank you for having me today. I'm going to make sure I share my screen real quick before we begin, so that's okay. Go. And there we go. All right. Thank you. Thank you for having me. So today I'm going to be talking about a recent publication of mine that was published in January of this year in Socius on race advanced math and the high school transition. And before I move any further with the talk, I want to just briefly say when I'm speaking about advanced math, what I'm speaking specifically about are those courses that provide pathways to calculus in high school. Thinking of calculus not as the only course or the most important course, but most definitely an important course in many ways. And so when I speak about advanced math and when I speak about accelerated trajectories, I'm speaking specifically about those courses that provide a pathway for students to calculus in high school in thinking about broader pathways to STEM majors and careers. Okay, and so I guess I begin with like, why advanced math? And when I study advanced math, often people go, oh, that's about schools. You're really interested in what parents want to know, right? Because parents are interested in what classes their children get into. But really advanced math, at least in the literature, has tremendous implications that extend well beyond whether a student gets access to a particular course or what a parent feels about it. So the research shows that advanced math, particularly taking higher level math courses, right? So the courses that take you to those higher level math courses, and taking those higher level math courses, especially calculus, is associated with larger learning gains with high school matriculation, right? So finishing high school, it predicts the prestige of the college you get into. It predicts your likelihood to go to college. It predicts your performance once you're in college. It predicts the likelihood you'll finish college. Advanced math, particularly calculus, also predicts the likelihood that you will major or take on a STEM major and follow a STEM career pathway. And there's research that suggests that it even impacts your wages in adulthood 10, 15, 20 years later. And the interesting thing about that study by Rose and Betts is that it impacts your wages regardless of what you actually majored in college. So it's not just predicted by being a STEM major, but even if you're not a STEM major, taking advanced math will predict higher wages in later in life. So the focus of the paper, of course, is looking at race and racial inequality in access and opportunity in advanced math. And when I'm thinking about race in advanced math, I'm drawing from two theories in particular. First, I'm drawing on this theory or this idea of schools as sites of opportunity hoarding. I've written about this idea of opportunity hoarding in another paper published in Educational Researcher on STEM majors at the university level as being a site of opportunity hoarding, where Black students and to some extent Latinx students are pushed out even when they're equally prepared. And so this theory has also been used by Amanda Lewis and John Diamond to discuss access to advanced courses at the high school level, right? And so I'm arguing that access to advanced math is a resource that is both limited and highly valued, and that it takes the perpetuation of stereotype beliefs becomes a key mechanism for maintaining a social advantage that provides advantage to particular groups and exclusion for others. I'm also drawing on this idea of schools as racialized organizations. Two important ideas come from this. The first is the idea that as racialized organizations or racial structures, schools can have a decoupling of formal rules from organizational practice. That means that even when you have rules that look like they can be equitable, it doesn't mean that the practice itself is equitable. And that when it's inequitable, it's often racialized in those environments in a way that, that prohibits access for minoritized youth. It also, in this research, Victor Gray argues that those who work in racialized organizations can reinforce the connection between these racial schemas, so these racialized ideas about students, and the actual material resources, so your access to courses, let's say, even in the absence of racial animus. So this theory is not just about this idea that people are racially biased per se, or have this racial animus towards students, but rather, even in the absence of some kind of expressed racial animus, that they can still reinforce a racialized system of inequality that is fed on this idea or these racialized stereotypes and schemas about students based on their race. So a lot of the research in advanced math has focused on either access to Algebra 1 in middle school or access to advanced courses in high schools. So we really don't know a whole lot about what happens in between middle school when you start and high school when you finish. And so my interest here was thinking about, so you get on this math track in middle school, and what happens next? Now the question begins first with thinking about this idea of curricular intensification. Why does it matter that we focus on the transition to high school? Well, it matters because in order to access calculus, the timing of Algebra 1 is pushed back into middle school. It means that a student must traverse the middle to high school transition while they're on that track. So they don't begin that track in high school, but rather begin beforehand and have to maintain that track during this transition to high school. And there's some work on this idea of the nature of school transitions. Generally, school transitions can be disruptive for students. Grades will go down at the start of 9th grade for all students, but Benner and Langenkamp find in particular that transitions can even be more disruptive for minoritized students. And Mizell finds that when our students are talking about the transition, their greatest worry, or one of their greatest worries, is actually around math and math course placements. And so this takes us this idea of curricular disruption. So Lovelace argues that, that because Algebra 1 is pushed into middle school, the students that are on this accelerated track to calculus are likely to face curricular disruption during the transition from middle to high school. And again, I mentioned this idea of this curricular disruption as being unequitable, right? And so this leads to this idea around shifting positional advantages, because curricular disruption may not be spread equally. That means that all students may not experience the same kind of curricular disruption on this pathway. One of the most common curricular disruptions that happens between middle and high school is the retaking of Algebra 1. So there weren't any national studies prior to the study on this, but local studies showed that it was not uncommon for between a quarter and a third of students to have to retake Algebra 1, even when they had done well in the course before. And the research shows that generally having to retake Algebra 1 in high school does not benefit students, not generally, and especially not students who performed well in the course previously. So my study focuses on 3 different research questions. The first one is just, does the likelihood of taking advanced math in 9th grade vary by race for students who are on the accelerated track, right? So thinking of one track, the accelerated track, and then also for students who are on a more standard track, right? So thinking about these trajectories students follow. My second question is just, are these within track differences by race fully accounted for by students' prior course taking and performance? So here we're drawing on some of the literature arguing that much of the differentiation we find in placements is actually about students' performance rather than other factors. And so in this paper, I'm thinking about disentangling the extent to which it's actually about prior performance or prior course taking relative to other factors. And if academic factors don't fully explain these differences, to what extent are the remaining racial differences mediated or moderated by students' interactions with parents, with teachers, and with counselors, and the involvement that parents, teachers, and counselors have in this process? And here we're tapping into the importance of parents, teachers, and counselors in the role of student development in transitions, and the impact of the actions and attitudes of these actors on students' course-taking decisions and trajectories. Nope, I'm gonna get it all out there. All right. And so just a little bit about the details of the study. So the data I'm using comes from the high school longitudinal study of 2009, Wave 1. This study is sponsored by the National Center for Education Statistics, which is the statistics and research arm of the Federal Department of Education. This is a longitudinal study that started with 9th graders in the fall of 2009 and followed them over time. I'm using the first wave, which was the questionnaire that was asked to students in fall of 2009. The population that I'm focusing on specifically is first-time 9th graders in public schools. I do also evaluate this for private schools, but there are particular reasons I focus on public schools, and I can talk more about that if people have any questions. But it's first-time 9th graders in public schools, so I'm not looking at students who are retaking, or stayed back and have to retake 9th grade, but rather thinking about students who are coming into 9th grade after that transition. For my quantitative specialists in the audience, missing values for independent variables were replaced using multiple imputation with chained equations. This just means that I was able to salvage missing data for independent variables using a multivariate technique. And the final sample that I'm left with is about 14,350 students. Now, the dependent variable that I focus on is based on students' course taking in ninth grade, specifically focus on the idea of whether they were enrolled in an advanced math course in ninth grade. And again, remember here, advanced math is speaking to courses that lead or have a pathway to calculus. And so in ninth grade, we're thinking about geometry as that course. So students were identified as taking advanced math if they were enrolled in geometry or higher in the fall of ninth grade. This also included students who might have been dual enrolled, so they could have been in Algebra 1 and geometry simultaneously. The important thing was, were they in geometry or higher in the fall of ninth grade? If they weren't, and they were enrolled in a course up to Algebra 1, they were identified as having taken a standard math course rather than an advanced one. And then the grouping independent variable I use is the 8th grade math track, because this is really important. We know that math is a very hierarchical and requires requisites that in some ways mandate that a student take a course to get to the next course to get to the next one. So the course they took previously and the track they were on prior to high school matters. So here we're focused on the 8th grade math track with a similar theme to what we saw for the dependent variable, where if the student was taking what we would consider an advanced course or a course that would lead to calculus, they were considered as having been on the accelerated track prior to high school. And if they took a course that was below Algebra 1 in 8th grade, then they were considered as being on the standard track. And these are the true tracks that I focus on when I'm thinking about students' trajectories. Now, to give you a little bit of a visual of what I mean by this, think of it like this. Most students, in order to get to their next advanced math course, have a starting point. For students who take Algebra 1 or higher in 8th grade, we know that they have an accelerated math trajectory. This is a math trajectory that would allow, through sequencing, to reach calculus in high school. And that pathway would take them from Algebra 1 in 8th grade to some kind of geometry course or equivalent level course in 9th grade. And that would be our advanced course. Whereas students who took a course below Algebra 1, this could be an honors Math 8, this could be Math 8, it could be pre-algebra. The idea being they are on the standard course, they didn't take Algebra 1. So we wouldn't expect them to be an advanced math course. We would expect that their next course would be Algebra 1. And so students who took up to Algebra 1 were standard, and we expect that to be the pathway. But in this paper, I focus on two forms of movement in these particular pathways. For students who are on the accelerated track, I focus on this idea of track disruption, where they are taking Algebra 1 in 8th grade or a higher course, and you would expect them, following that blue arrow, to be in geometry or higher, but when you check what class they're taking in high school, they're only taking a course up to Algebra 1, right? So this would be a track disruption, where they would not be staying on the accelerated track and thus not be taking advanced math. The other pathway that I focus on is for students on this standard track. So these were students that weren't on the advanced math track before they got to high school, but some of them are able to, by different means, could include taking a summer course, could include dual course taking in high school, or testing out of a course, are able to kind of jump into an accelerated track in high school by getting into geometry, even though they hadn't taken Algebra 1 in the previous year. And so I'm also looking at this idea of getting on the accelerated track. So staying on track and getting on track. You'll hear that a little bit more as we go through. My key independent variable is race, and these are the racial groups I focus on. I'm known for focusing on racialized subgroups, and I do that specifically because these students do not always have the same experiences, and it's important that we understand the racialized experience of Latinx youth and the racialized experiences of Asian youth from different regions of Asia who also don't have the same experiences in school as I find in other papers that I've written. And I include in my modeling other independent variables. For student background, I include a gender and socioeconomic status, which is a composite variable made up of students' parents' education, income, and occupational prestige. I account for 2 prior academic factors. One is their previous course grade, because we often think about the grade they get in a class as being extremely important for how they'll do in the next one. So of course, a higher grade we would expect a greater likelihood of staying on track. And then I look at 2 measures each for parents, teachers, and counselors. There's one question that specifically focuses on whether you talk to either a parent, a favorite teacher, or a counselor about your course taking options, your math course taking options. And then the other set of questions asks whether they took this course because of the encouragement of a parent, encouragement of a teacher, or the recommendation or suggestion of a counselor. And so I'm looking at both the conversation itself that they're having with these adults and also the impact of the recommendations on students' trajectories. And for my quantitative folks, I won't spend long on it, but I use weighted distributions in stage 1. For my modeling strategy, I use logistic regression with school fixed effects. This is important because school fixed effects allow me to account for school level differences, so differences between schools, so that I'm able to attend to differences within schools, because the overwhelming majority of the variation in who stays on track is actually between students within the same school, not between students in different schools. I use a fully interactive difference in differences model. This just means that I'm able to model all of this different stuff at one time. I can model both the main effects for students in each track separately, and also model the interaction effects or the differences between students who are in the advanced math track and students who are in the standard math track. And then I use a modeling strategy that builds on a baseline model of race and then adds on to look at how the addition of each additional factor impacts my baseline findings and which are the racial differences in access to or course taking in advanced math in 9th grade. So as a starting point, just to get to some findings, because I know we don't have too much time, these are the actual weighted probabilities of enrolling in advanced math in 9th grade by track. And so the important thing to notice is about 76.5% of students on the accelerated track stay on track, right, by taking advanced math in 9th grade, and about 10% of students on the standard track get on track. This 10% is actually in line with other research. What's really interesting is the 76% suggests that there are nearly a quarter of students that aren't staying on track. This is important because much fewer students than a quarter actually fail the course or get a D in the course. So there are students in this 25% who passed, some of them who even got Bs and As, who somehow ended up retaking Algebra 1 or some other course that was not an advanced course when they got to high school. Okay, and so what I'm gonna do here is just give you a sense a little bit of the differences between the groups, and then some of the impact of the different variables. So just quickly, the likelihood of staying on the accelerated track, there's a line here. The line is the average for everybody. Here go my different groups. Orange is below. That means that these students are less likely to stay on track. The students that are above are more likely. So you see clearly here are the Black students, Latinx students are less likely to stay on track. East Asian and South Asian students more likely, and then white students and Southeast Asian Pacific Islanders are about on par with the average. If we look at the likelihood of getting on track, even though we saw that 10% as average, notice that 10% is not distributed the same way across groups. So if we look here, you'll see that the 3 Asian subgroups are more likely to get on track than the average, where when you look at students who are Black and Latinx, you see that they're less likely. And there's also some variation among these students, but we see that they're a little bit less likely. But here you notice that the Asian subgroups all stand out in terms of their likelihood of getting on track. So what do these differences look like within schools? So these models just focus on the impact of our baseline, background, performance. So what happens when I account for these different things? So notice there's a baseline of 1. These are odds. A number below 1 means that they have a lower odds than white students. A number above that line, but above 1, means that they have a greater odds than white students. If the box is filled, that means that it's a significant difference. And so you'll notice immediately Black students, Black Latinx students, non-Black Latinx students, white Latinx students, all below. And again, East Asian students slightly above, South Asian students far above, and Southeast Asian and Pacific Islanders a little bit below, but not much. If I add on the background, so this is attending to socioeconomic status and gender, notice there's a little bit of a change, a little bit of an explanation and a reduction in those gaps. For Black students, a little bit more for Black Latinx students. This is largely an SES effect. You'll also notice that that SES explains the differences for non-Black Latinx. So this is like our brown Latinx group, and for white Latinx students. So these gaps close once we account for SES. That is not the case, notice right here, for Black Latinx students. And I want you to notice that when we account for performance, and by performance, I'm saying the previous grade, the grades they got on the prior course, and also whether they took a more advanced form of the course within their track. So for students on the advanced track, that would be taking geometry or higher in 8th grade. For students on the standard track, that would be taking like honors math. And so if I account for that academic performance, notice there's really little change for Black and Black Latinx students, that their difference is almost not at all explained by their performance in the class. There is some explanation. It closes slightly the gap for East Asians. It's, you notice the gap for South Asian and Pacific Islanders closes, but look how large that gap is for South Asian students. This means that South Asian students, even after accounting for performance, have 4 times the odds of staying on track than similar performing white students. And then it's even higher if you compare them to Black students and Black Latinx students who have similar grades and are taking similar courses. And remember, this is all within school. So this is compared to their peers in the same high school. Now, if I focus on getting on track, you'll notice that when we look within schools, really the difference here that stands out is that all the Asian subgroups still have a greater odds of getting on the accelerated track. I'm going to move through background quickly because it has really no impact. When I get to performance, notice there's just a slight change for East Asian that renders it insignificant, but it doesn't move the actual line much. But notice that South Asian students and Southeast Asian and Pacific Islanders remain significant, which means that they continue to have higher odds of getting onto the accelerated track in 9th grade, even when they are performing similarly to the white students that we're comparing them to here. And those significant differences hold for some of the other subgroups as well. Okay, so parents, teachers, and counselors. Just a quick rundown of some of the things that matter and what doesn't matter. So first, what matters for staying on track? Talking to a parent matters. Gives you a 40% higher odds of staying on track. This is for everybody. Being encouraged by a parent matters. Not surprisingly, 81% higher odds of staying on track. And then being encouraged by a teacher leads to 131% higher odds of staying on track. I have that little star here to note that being encouraged by a teacher matters much more for students on the advanced track than it does for students on the standard track. So students, for staying on track, this encouragement for teachers matters even more than it does for other students. Now, what matters uniquely? And by what I mean by uniquely is it means it doesn't matter for everybody, but it does for certain groups. It was really interesting. I found that talking to a favorite teacher mattered, but it only mattered for Black students. And this for me wasn't surprising, though I think it was for many, because there's some literature that talks about how Black students regard their teachers. There's one study in particular that touches on this idea that Black students are the only students that are more likely to regard the opinion of their teachers over their parents in terms of their own performance and their thinking of their self based on that performance. And so when a Black student is taught to a favorite teacher, that increases their odds of staying on track by 200%. It is large enough to close the gap between Black students and white students. So here, a favorite teacher matters. But sadly, talking to a counselor doesn't have that same kind of effect. It doesn't impact most students, but when it does, particularly for Black Latinx students, it actually decreases their likelihood of staying on track, even when they're performing at a similar level as other students. So Black Latinx students who talk to a counselor have an 80% lower odds of staying on track than if they didn't talk to a counselor. So they benefit from actually not having that interaction. What doesn't matter? Having course suggested by a counselor. Quickly, just to getting on track, talking to a parent matters, being encouraged by a parent matters, being encouraged by a teacher matters. Talking to a favorite teacher matters for South Asian students, but it reduces their likelihood. The interesting thing about this is that in this case, it's actually tempering their much higher amount. So it may be in this case that the favorite teacher is noting that that student may not be ready for the advanced math track, even if generally they're usually jumping the gun and way more likely. What doesn't matter? Talking to a counselor, having a counselor suggest the course doesn't matter either. Final results show that there are still remaining gaps. Black students still have a 46% lower odds. It's particularly true for Black students who don't talk to a favorite teacher. Black Latinx students have a 53% lower odds. South Asian students still have a 311% higher odds of staying on track. And South Asian students and Southeast Asian and Pacific Islander students have higher odds of getting on track. So what can we do to address these issues? Some of the things we can improve opportunities to learn in middle school. One of the interesting things I found was that grades did not matter at all for Black students. And when you account for test scores given grades, and these are test scores done by the study, not by the school district, the test scores explain a little bit of the gap, net grades. What this tells me is that Black students are not receiving the same amount of information or opportunities in the courses they are taking in middle school relative to their white peers in the same high school, which may mean that they're going to different schools that aren't offering the same level of rigor. We should consider the role of teachers for Black students, this importance of teachers serving as role models and having a relationship that students can then reach out to that teacher as a source of information and a source of support. We really need to examine why counselors have either no or negative impact. I did not find a single case where a counselor had a positive impact. In every case, they either didn't matter at all or they had a negative impact. And I find that this negative impact extends in work I'm doing now to also students that have lower socioeconomic status backgrounds. And then we just need to deal with these race and class-based biases. There are some actions being taken that are tied to race that are not tied to student performance, which is not only reifying the inequality that's already set up in middle school, but in fact, magnifying it, right? By increasing the gap in this transition, even among students who are on the same track and performing at the same level. And we need to deal with structural barriers. What are the barriers that leave the onus on students to figure out how to navigate these pathways? Access to information, possibly testing barriers, other kinds of barriers that aren't really relevant for the next course, but are being used as gatekeeping opportunities, or access to information about ways to maintain or stay on track through dual course taking and other opportunities. Some students are getting this information or have it, other students don't. And some of those differences are along racial lines. So with that, I want to thank you for attending my talk today. I want to acknowledge the American Educational Research Association's grants program, the Ford Foundation Fellowship Program, and the Population Research Center at the University of Texas at Austin. Thank you so much.
Awesome. Awesome. Thank you again so much, Dr. Irizarry, for coming and sharing your work with us today. I want to give a quick reminder to all that you all can share your questions using the Q&A box at the bottom of your screen. And Yeah, so just starting off, um, I think this is a question that you've already answered, I think specifically on the details slide of your presentation, but I think just to clarify for in case of any confusion,
Yes.
there's one question that says, does advanced math mean only high school advanced math as a predictor of higher earnings, high school completion, college work, etc.? Or does K through 5 or K through 8th grade advanced math also matter?
So the work that I'm drawing on is specifically connecting the final courses students take in high school. So the highest level of courses that they access in high school with later performance. And I think a lot of that may just be data limitations. There's not a single study I know of that follows students from kindergarten through, past university to life course. Many of the studies that do follow students into adulthood start at the high school level. And because of that, we have limitations in terms of tying early performance and early access to what happens with income. But we do have research that ties earlier experiences to later ones, right? And so we can think about the connection of K through 5 math as a starting point for the experiences students have at high school. And so to give just a little anecdote, I teach a course called Numbering Race. It's actually the first math course in Black studies in the country. It is core math in the state of Texas. And I teach this course almost every semester at UT. And I get students to come to this course and they're very scared of math. I do a lot of kind of triaging around math fears. And what I've discovered over my many years of teaching this course is that students' traumatic experiences with math, the ones that derail them, the ones that change and shift their thinking, from going from I can do this, I'm good at this, to I'm not good at this. Not only do they remember the year and the teacher, but for many of my students of color, particularly my Black students, those experiences happen much earlier. So not experiences that are happening in junior, senior year of high school, but rather experiences that are happening in 3rd and 5th grade. And so this kind of like elementary, middle school period. And so those teachers do matter, because if a student is derailed at that point, there is no chance they're going to get to, or very little chance they're going to get to, those advanced courses in high school that we know matter so much for these pathways. So yes, it does matter, but there isn't research specifically linking that kind of long trajectory in the life course.
Very helpful. Very helpful. Thank you. Okay, just going down to the questions we have. Another question was, did high school placements have any relationship to the confidence and the quality of instruction at the attended middle school?
That's a good question. So I actually, in other iteration of this paper, which is not part of the final paper because it probably will be another paper, I actually looked at whether the students transferred from a school that was in district versus out of district. My thinking being that if a school is in district and offers Algebra 1, that we should have confidence in their teaching. And if we don't, then that's on the school district, not on the student. Because if a school district is coordinating curriculum, then any math course that a student's taking that is supposedly called Algebra 1 should be teaching them Algebra 1. And if there's a lack of confidence, then that's a racialized problem, especially if that lack of confidence is driving racialized differences. But I did look at kind of this between district, right? So students that changed districts or came from a private school or somewhere else rather than in district. And I did find some differences. But what I found was those differences didn't explain the gaps or the differences for Black and Latinx students. It didn't attend to those at all. So there was this impact where there was less trust. And so there was more disruption in a trajectory if a student came from out of the district versus in the district. But it didn't reduce the gaps and it didn't moderate them. So it didn't attend to this kind of like inequality, particularly for Black and Black Latinx students or for South Asian students on the advanced math track.
Awesome. Thank you. Yeah, I think another interesting question came from the audience was whether there were any significant gender differences by race as well, because I know that was one of the that was another variable that was in your model.
So there actually weren't. So I ran interaction effects on the entire model to look at general patterns. I only attend to in the paper the interaction effects with parents, teachers, and counselors. But I did run others to give me some interesting insights. Gender didn't matter, but there was an interaction effect with grades. What was interesting was most of the gaps I found between students for grades was actually in students performing in getting A's and B's, not the students that were failing. So most of the gap was actually driven by high performers, not low performers. But I did not see any gender differences. Gender was not a significant predictor throughout most of the model. When it was very, very mild, and it did not interact with race.
Interesting. Okay. Thank you for clarifying that. Okay, another question is it correct to understand that within schools is grouping students by their high school and not middle schools? And this question from the audience goes on to say, is there any way to look at the effects of middle school of how common the accelerated track is within school? And this kind of goes into the fact that in some schools, algebra in 8th grade is uncommon, while in others, that accelerated track is the norm.
Yes. So within schools does mean grouping at the high school, because the idea was if differences emerge, they would be within a school with the same policies. So we see differences for students that are similar on the things we would expect to impact their background, then we would see that decoupling, right? The decoupling of the policy from the practice. But you're right, there are differences in middle schools and accelerated track. The model does attend to that in the fact that I focus on track separately. So it doesn't attend to, let's say, the likelihood that a student has access to Algebra 1 in 8th grade, but it does address the fact that if they have access to Algebra 1 and are able to take it, what does that trajectory look like? But you're absolutely right. There are differences in access to these courses. I'm not currently doing work on access to Algebra 1, even though the data is available. I'm focusing right now in another study on access to calculus, looking at the civil rights data nationally and the level of racialized tracking, or the extreme, like the magnitude of racialized tracking in public high schools in the US. And much of that is a manifestation of inequality happens in the middle school. Some of that inequality at the high school level is a lack of, or an entire absence of calculus. And my guess is to some extent at the middle school level, we may see a similar thing where for some students in the middle school level, there's going to be a lack of access to Algebra 1. But as an interesting side note, the reason I also focus on within schools is because between school differences actually reduces gaps, not increases them. This is because even though schools that are less resourced, which often tend to be have more minoritized students, even though those schools have fewer resources, when the courses are available, Black and Latinx students have greater access to them. Racialized tracking is the idea that when schools are desegregated, Black and Latinx students are blocked out of these advanced courses because they're seen as an important resource and opportunity, right? An important signaling. And so students in these desegregated spaces actually have very little access to those courses. They're blocked out even though courses are in the schools. But in schools that we tend to think of as less resourced, when the schools have the course, those students have free reign to those courses because they're not competing against this kind of a racial hierarchy of students that's blocking them from gaining access to these particular courses through a lack of information or through racialized attitudes or whatever the mechanism may be.
That's very interesting. That's fascinating. I'm still just thinking about that. But yeah, thank you for just bringing up the distinction of the between schools and within schools and the reasons for those differences. So in the spirit of To and Through, we are all about connecting research and data to practice. And so there's one question from the audience that I'd like to bring forward, which is, to what extent have these efforts and practices trickled down to high school and middle school in Texas public schools? And if I can add to that, what takeaways would you have for practitioners if these types of efforts and practices have not been implemented yet?
Okay, Well, I would say, so the publication just came out this year, so there most definitely hasn't been any actual, I would say, like trickle to policy. We know policy does not work fast, especially in our great state of Texas, where the legislature meets like every several years and things don't get done. And the focus isn't always on education, or when it is, it's on other things within education. But this doesn't mean that it hasn't had an impact. What's been interesting is that the biggest impact I've seen so far has been in my talking to STEM programs at the university level, and the greater effort that universities are making and programs are making at the university level to extend to provide resources and support to students in middle school. Looking at the importance of connecting those, rather than thinking about, oh, can we get students to calculus and focusing on high school, thinking about those moments of disruption very early on that disrupt the trajectories, that leave students unprepared or less prepared for college, and that also create racialized environments in schools that reinforce everybody's ideas about who can do math, who can be a scientist, who can be in STEM, which is what these racialized environments actually do, right? So it's not just about who does and doesn't get access, but when your advanced courses are predominantly white and Asian, you're not just blocking access to Black and Latinx students, you're signaling to white and Asian students that they are the students that have worked hard and supposedly belong in those classes. And that thus those students that aren't in those spaces don't belong in those classes. And those white and Asian students that perform in those advanced courses become our professors in STEM programs and other programs. They become our policymakers, they become our doctors. And they head to those careers with those ideas that they succeeded because they worked really hard. The students that weren't there must have not been working hard, and thus that defines the people they treat, the people they supposedly are advocating for if they're doing policy, the students that they're teaching if they're at a university. So this matters on many different levels. And I'm hoping that it will also, trickle down to, to the high school level. I've got a little bit of feedback on some work that's been done in different states around like refunding some of the middle school programming around math to try to reinforce that to kind of strengthen students' pathways. But I think there's so much more that can be done, and I don't know how long it'll take to actually kind of transition this, because this isn't an easy fix. It's not like, oh, I've got something for you. Everybody, all the teachers just be best friends with all the Black students and all of a sudden we've resolved math inequality. It doesn't work like that. It's much more complex. And so I think that it's going to take some time to see some of the impact of this work and other people who are doing work similar to this within the schools.
Awesome. Thank you. And I think a follow-up question, just in terms particularly of the counseling aspect, because I know that's a bit of a stark finding as well, is just what other information you have about the counseling that students got. Were they counselors that had particular expertise in academics, or were they just general counselors? Was that data you all had access to? And this is just to elaborate from the audience member who asked this. They're wondering about what could impact that relationship and the trajectory for those students compared to the positive impact that was happening with teachers for Black students particularly.
Yeah, so the data set does have some information, but the problem was that there was a mistake in the data set early on. And there was a contingency question that was not well worded, and the result meant that some of the counselors answers questions they shouldn't, and others didn't answer them, even though they should have. My paper originally started as a project that was going to focus on counselors and was going to focus on the role of counselors, because this was the first time NCES had done a study where they actually surveyed the counselors and what the counselors said mattered for placements at the ninth grade level. And so I was really excited. And then I got in and discovered that this error meant that we lost a large number of counselors and that it wasn't random. And so, I am a methodologist at heart, and I cannot in good faith analyze data that I think does not reach a particular standard of quality for ensuring that our results are robust and that really lead to policy that can impact students' lives. And so I ended up having to switch from using the data that collected on counselors to the data that was collected from students. And that data was a little more vague, right? So it wasn't, it didn't give much details about who the counselor was, but rather whether that interaction had happened. So it could have been a counselor at the middle school level. It could have been a counselor at the high school level, or it could have been both, because different districts have different practices for how they do that, right? Some districts have a middle school counselor that works with the high school and that helps the placements. Some bring high school counselors to the middle school, right? And so there's different ways that that interaction can happen. And I think that there needs to be a lot more work exploring it. There's just very, very little work on counselors. As I was trying to build out the literature, I mean, I found literally, I could count on one hand the number of papers I found actually attending to the role of counselors in terms of placements for mathematics in any kind of way. And so we really need to do more work to think about why it is that, at least in the case of the work I've done, I'm not finding a positive impact. And there is at least one other study done by Dania Francis that looks at guidance counselors and placements for Black girls in more advanced math courses, and also found a negative impact of counselors. So my paper is not the only one that's found that counselors can have a negative impact. And I have yet to find a paper that suggests they're having a positive one. So we really need to think and address this, because many schools are depending on their counselors for both providing information to students and providing them opportunities.
Thank you for clarifying that. Yeah, I know that certainly sounds like just an area for further exploration and understanding. Okay, I think another interesting question is from the audience is, for the students who take advanced math, are they taking other advanced classes as well? I think this audience member is curious to know if there are similar results for something like advanced English, for example.
No, that's a good question. They may be, and the transcript data may have that. It's not something I looked at specifically. That's partially because the data set I was focusing on, the HSLS, really had a STEM focus. And so the courses were really around math and science when they did ask things. And I particularly focus on math because other courses, even if you're taking advanced or not advanced, often aren't sequenced. So the movement into, let's say, an advanced or honors English in ninth grade is not dependent on your honors English in eighth grade, right? You can make that jump. And as long as you can show that you can handle the rigor of the course, you can make that jump. With mathematics, you can't just make that jump. Even if you show the rigor, you need to take the previous course, right? And so there have to be all these mechanisms to ensure that you can maintain that trajectory. And so for me, focusing on math seemed extremely important because it was the one pathway that was a high school pathway that was started in middle school, and that required a maintenance of a sequencing in order to stay on track, which is a very different than almost any other subject in high school, where there isn't this very tight dependence on one class to the next, and a need to take so many classes to get to the highest level. 5 classes to get to calculus in 4 years, right? You're either doubling up or you're pushing into middle school. And the most common practice is to push into middle school. And so that's where my focus on mathematics was specifically thinking about the way that that pathway can create a particular type of disruption that is unique to math, right? And unique to students who are on that particular pathway within mathematics.
Okay. Thanks. Thank you. Yeah. And so I think we'll just have time for one last question, because I know we are planning to end at 1. So I think last question would be, do you have any data on the impact of teacher qualifications and training, specifically for those teaching the accelerated math courses to middle school students particularly?
Yeah, so I don't right now. I have been waiting. NCS has a middle school study, and I've been waiting for the data to be released. It seemed that there were some issues with the first wave. I think they had some issues with participation rates. And so the first wave wasn't released, and I've been kind of waiting for it, because that would be the first study. I think this is like one of the first middle school studies. I've been waiting forever for a middle school study. I mean, I'm really relying on ninth grade information to think about middle school, because middle school data isn't available. The only other middle school data is from the educational, the ECLSK, it's like an elementary It follows from kindergarten through 8th grade. This is the 1999 cohort. But by 5th grade, they had a lot of attrition. So looking at 8th grade is almost impossible with that data set, especially for the type of variation I'm interested in. But this middle school study, because of the way NCS does their data collection, would have information on their teachers and their qualifications and their training, and then would also have data on the students and their performance and their feelings about math and the courses they're taking. And so with the release of this data, I think we will have a chance to look more at the connection between those things. Now, I'm not currently looking at that, but I do have I've already launched a pilot study funded by the Bill and Melinda Gates Foundation for the first national study of high school math teachers, where we actually look at teachers' background, training, practices, and racialized attitudes. And so right now we have several hundred teachers who've participated. Our goal is to get to several thousand. And while we can't connect it to specific students, what we can do is identify particular types of practices and ideologies and connect those to training, background, and school context in a way that gives us a sense of the different kinds of ways math teachers think when they're approaching learning, the extent to which they draw on deficit narratives, or do practices that aren't inclusive in their classroom that may exclude students, or that do or don't promote particular practices that may reinforce inequality in access to courses, so on and so forth, that can give us at least a window into the background, the training, and the thoughts, the ideas, the attitudes, and the practices of math teachers in the classroom.
Absolutely, absolutely. I think that's data that a lot of people will be looking forward to having access to and working with. So that's good to hear. All right, well, I think that's where we'd like to end for today. Again, Dr. Irizarry, thank you so much for joining us.
Yes,
and thank you to everyone in the audience for joining us today. And just as a heads up, the 2 and Through team will be having a spotlight on Thursday, November 4th from 11 a.m. to 12 p.m. Central Time. And that's happening next week. And so that will actually be on investigating educational attainment for CPS students from a community perspective. So we'd like for you all to join us for that event as well. Again, thanks you all for joining, and a major thank you to Dr. Irizarry. All right, see you all.